Yeah, so good evening and good morning and good afternoon to all of you who have joined this 50th CRE lecture. It is an important milestone for the CRE lecture series as well. We have reached about 50 lectures now, and with today's one. So today we have a very important guest speaker, Professor Lee Masson Pascal from the PSL University. And I have the pleasure of briefly introducing him and his work. So Professor Pascal heads the chair of Bauhaus transition, which is essentially looking at how do we transition to deal with more global issues that the world is encountering today, and how design can play a role in terms of bridging the gap between technology and management. So they have been involved in some good work in terms of the development of the CK theory and its application to the explaining issues in engineering design, as well as looking at organizational issues in terms of propagating design in organizations. Pascal is also a member of the French Academy of Technology and also the co-chair for the Design Theory Special Interest Group under the Design Society. With this short, brief background, may I welcome Pascal to share his presentation and walk us through his views on managing the unknown and introduction to the CK design theory. Just to give you a quick brief, Pascal, most of the audience here is part of the centrally funded government institutions, their faculty there. And there are also some mentors who are part of one of the programs we are currently running called the Capacity Building on Design and Entrepreneurship. So I see a lot of relevance of the CK theory in that context as well. So we are very happy to listen to your views on the whole process. Thank you and welcome.
Thank you, Sudhir, and thanks a lot for the invitation. I'm very honored to give this lecture and to have the opportunity to be one of the long series of courses that you recorded. And I really thank you for the whole initiative, because this is kind of heritage we need if we want to think what is design, what is innovation today and for the world of today. So really, I'm very happy to have this opportunity to present these works and discuss with you how it can be useful in the future. Yes. So PSL University, I won't go too deep in this, but we are one of the institutions inside PSL. PSL is now a quite big university. We used to say that we have something like sorry, I'm looking for the exact figure, but 28 Nobel Prize, which is the usual way to explain we are very important. My institution is one of the institutions here, and historically speaking, we were in charge of educating, training the mining engineers. So we keep the name mine, even if now we teach engineers for many different disciplines. So we are active in all the branches of engineering sciences. But from this heritage, we keep the idea that an engineer might be at the crossroad of many different knowledge. And inside PSL, we are in an institution that kept this tradition of a so-called generalist education. So our engineers, they are a little bit familiar with many different branches of engineering sciences. And inside PSL, my institution tries to be in contact both with humanities and social sciences, but also basic sciences with the École Normale Supérieure. We are very close to classical business management, but also to design and art. So we try to really provide, and I will discuss that point later, to provide a language that helps different types of designer to interact and prepare the future. So this is why I insist a little bit on this strange PSL institution. This is a usual university, but inside this usual university, we try to really provide this integrative language. In particular, this Bauhaus for Transition is the institution where we conduct our research, and we have a very solid research program on how to have the management adapted to the transition for tomorrow, and we call it managing the unknown of transitions. And we consider that if we want to be rigorous, and this will be the kernel of my talk, if we want to be rigorous in the way we manage the unknown, design effort, design theory might be one part of the solution. If you are a good designer, you are more rigorous and more creative to manage the unknown. This is what I'm going and try to explain. This program is funded by a couple of important companies. You see the logos here. I won't go too deep in this, but just to mention this, they not only fund us, but they also explain when we opened that new institute, something like a big year ago in March 2024, they published an opinion in one of the leading economic journals in France, a newspaper, and they explain that they fund this institute because they say major challenges call for managers capable of managing in the unknown. So really this is for them a key issue, having a new generation of managers capable of rigorously act and help the company act in the unknown. While from a more academic point of view, we publish both in management science, and Sudhir, you know all this, but we also publish in engineering design, and Sudhir, you also know all this. And in engineering design, we are in charge with SUB, we are in charge to organize the activities around design theory. So we try to make that this community of design theory progresses and have regular advances, etc. So we meet regularly. We have a yearly meeting in end of January, early February each year in Paris. And we even have a tutorial for PhD students to help them accelerate in their learning process and be able to really tackle with the most important research topics. This is quite a living community. It's a big community, and Sudhir SUB, you can certainly build on this next. And of course, you are all warmly invited to the next meetings of this design theory community. For today, what I had in mind for this presentation is precisely to explain this logic, design theory for a better management in the unknown. I will take a while to explain the issue of managing the unknown, explaining why it is not the classical management. We teach management in my institution. We are a management science laboratory, and we are in charge of teaching management to engineers or to business students. And for years, we taught decision-making, of course. But when it comes to complementary questions, this is different. And decision is not enough. It's necessary, but it's not enough. And this is what I am going to explain. We need to be more rigorous in the management of the unknown and not only in the management of the uncertainty. I will explain this difference. This is a key difference, and explain also that if we make this difference, we understand that to be rigorous in the management of the unknown, it requires, and this will be my second point, it requires to have a good design theory, a rational one that accounts for the specific logics of exploring the unknown. And I do that on the second point. And I will illustrate this management of the unknown based on design theory on at least one case. I prepared others, but I wanted to show you one case where we used design theory to manage the unknown. And this is not a classical innovation case. It's a crisis case. This is how to make use of design theory to handle a crisis situation. So my first point is a question of managing the unknown and why managing the unknown is not managing uncertainty. As I explained before, in management science, we are, in a way, expert of decision-making. Maybe you don't know this, but this book, Applied Statistical Decision Theory, which is a basic in decision-making, was actually a book that is not only forwarded by the director of research of Harvard Business School, but it was even funded by the Harvard Business School. they paid for having a book explaining the rigor of decision making. So business teaching, management science supported the development of a very, very rigorous theory of decision. This was in the 50s. Today, we have additional problems. And to explain where is the difference, the classical decision-making situation is, for instance, that one. And this situation resulted in many, many papers in Science, Nature, etc. Jean-François Bonnefond was one of the leading authors of this experiments, worked a lot on this kind of decision in a digital world. So the question is, you are a designer of an autonomous car, and should you design the car so that in case like this, the car decides who is going to be killed. So the situation is, this is an autonomous car driving in a city, and suddenly the brakes are out. And the car has to decide, does it go straight forward and kill the pedestrians, or does the car shift, avoid the pedestrians, but killed the occupants, the passengers? So should you decide to kill the pedestrian? Should you decide a program that kills the pedestrian, or a program that kills the passengers? And you can frame this as a decision problem. No, this is quite self-evident. And based on this, you can, of course, make a lot of experiments to compare the situation depending on, well, who is programming, in which country, for selling in which country, whatever. And you compare culture, the indecision, blah, blah, blah. And one day, a newspaper say, what if you really ask an R&D manager? So they ask a top-level R&D manager in a big company, and they ask him, would you choose A or B? Would you recommend to your engineers to program the car for killing pedestrians, or to program the car for killing passengers? And, well, you certainly know this kind of situation, but the answer of the management was immediately neither A nor B. Because whatever the situation, it will never work. If I sell a car that is killing pedestrians, this car will be forbidden in this country. And if I sell a car that is killing passengers, this car won't be bought. So anyway, this will never be A, and this will never be B. So my situation as a manager is not to decide, it's to push my designers to explore CDE solutions where there will be 0 accidents and 0 injuries. And this is an interesting point. This is where we shift from a situation of managing with uncertainty to managing in the unknown. This is not a decision-making situation. This is a situation where you have to design a new decision set. You see the big difference. So this is just an example. But if you follow this logic, managing as deciding, in many, many situations, managing as deciding versus managing as designing, in many, many situations, you won't manage in the same way. You can take the gray table on the bottom right. Managing and deciding for innovation is immediately considered as reduced uncertainty, have a good expected NPV, think about combinatorics, optimization. If you are in a transformation or transition situation, you think about deciding dilemmas, planning for the future, optimize things, etc. If you are in a crisis situation, you think of commando team and bricolage with existing resources. This is managing as deciding in 3 different situations. And now compare that as managing as designing. Innovation becomes exploration, disruption, breakthrough, new business model. Transformation becomes multiple design forces, design project, ecosystem design. So thinking the variety of explorations. Crisis might become coordinate, scattered, creative forces. So it's not a commando, it's completely different. So you have 2 different paradigms. You can think as deciding or think as designing, and this will drive you in completely different completely contrasted ways of managing in innovation, in transformation, in crisis. And of course, I'm going to explore with you this second column, what is managing as designing and how to do that correctly. So now I go a little bit further in the question of what do we know about managing in the unknown, or managing as designing. Interestingly enough, and I won't go too long on this, but I could spend more time, dealing with the unknown is not something new. If you take a scientist, he's used to dealing with the unknown. Enigmas, anomalies, questions. This is the life of a scientist. If you think of technologists, engineers, they also are quite at ease in providing new technological solutions, in addressing new needs, in using science differently. So in a way, they are experts in managing the unknown. In art, of course, artists, industrial designers are also experts of unknown in art. Even in commerce, that's interesting, it's historically less known, but when you are an expert in commerce, you will be very sensitive to unknown of techniques for computing, unknown of geography, unknown of language, so or law or legal institutions. So even commerce, if you are a tradesman is someone that is trained in managing the unknown. So this is not that rare. So where is the problem? The problem is that we tend to consider that this is an individual competence. And we consider that you as a scientist, you should deal with the unknown, you as a tradesman, etc. You should do that on your own, and management starts after that. So management starts when the unknown is solved, and we just have to coordinate in the known. And of course, this might have been true in the past, but it's not true anymore. And that was explained already quite long ago by a French philosopher of technology. And he explained that already in the 1980s, the global level of technological knowledge in our society was extremely high. But the relative level of scientific knowledge or technological knowledge that each individual has is constantly decreasing. Over time, each individual has always less and less percentage of the global technological knowledge required for living in the world of today. So you have a decrease of the relative part of technological knowledge, meaning immediately that discussing, coordinating between all these small pieces is increasingly important. So managing as unknown is precisely the moment where you need to have new ways to discuss expertise in an unknown world. So finally, the critical issue becomes managing in the unknown is to provide an integrative language that enables many experts in the unknown to work together in the unknown, which is not exactly what we tend to teach when we teach scientists or when we teach artists, for instance. So now the question becomes how to rigorously, collectively explore the unknown. And might sound strange, but from a scientific point of view, the question is a quality control. Are we rigorous when we explore the unknown? And the experts in cognitive science, they tell us, well, be careful, we are not. They immediately tell us, confronted to the unknown, even if you are expert, you tend to not be that good. What is the phenomena behind it? This is something that is quite known, and you've certainly heard about this. When we explore the unknown, we are victim of a terrible cognitive phenomena. We are fixed. This is a fixation. And what is a fixation? It describes the way that even if apparently there is a large universe to explore, we tend to explore only a part of it. And to give you an illustration of a fixation, imagine that you have to explore the universe of solution to make that moving just one match, you can get a square out of the shape you have in front of you. You see this cross here in front of you. And the question is, explore all the solutions to find a way that with only one move of one match, you can get a square. So you can try to be creative on this, etc., but we have not time for this. What is funny is that one solution is that one. What you get here is a 4, and 4 is a square. This is a square of 2. And you understand immediately this is this kind of stupid game. You understand we were fixed in our representation of the exercise. Remember, the exercise is how to make a square by moving one match, but I added a picture, and the picture fixed you. And we immediately think, oh, this should be a geometrical square. But I never say a geometrical square in the question. So finally, the question fixed us. Think now, if we have to reinvent car industry, if you have to reinvent electricity and energy supplies, if we have to reinvent agronomics and food, drug, etc., if the phenomena occurs with just this stupid exercise, fixation, if fixation occurs just with this stupid exercise, what happens in the situation where we need to revise in more depth our way of living, our way of thinking, our way of modeling, our way of making science, technology, etc.? So fixation is probably one key issue. And we could reframe our initial question by saying, finally, the question of exploring the unknown with a maximum of rigor could be reframed in a quite simple illustrative case. Suppose that given a certain innovation challenge, you want to be rigorous and you organize the exploration. Your team is supposed to have ideas, and they work, they develop an innovation process, they explore the unknown, and after a while they come back to you, their manager. You are the manager here. They come back to you and they have a list of ideas here. And for each idea, they can even tell you whether it's interesting, frequent, valuable, etc. Of course, you can decide here, but my point is not that one. My point is you have to manage the unknown, and in particular, you should wonder whether the list of ideas is fixed. Are you sure that you really have in front of you all the imaginable ideas? Suppose that this red line that you see here is describing all the imaginable ideas associated to the problem. Maybe your team is in the bottom. They worked well. They covered all the imaginable ideas. They were not fixed. What if, finally, even if you have the impression there are many ideas, these many ideas are only covering a small set of all the imaginable ones? They were fixed, and you have to manage this fixation. So we would be very happy to be able to rigorously, one, diagnose if there is a bias, and can we measure this bias? If there is a bias, what are the causes of this bias? And third, if there is a bias and we can identify the causes, can we in a way help the team to overcome this bias? Manage the unknown is to help the team to diagnose the bias, explain the causes, and overcome the bias. So in a way, you understand, managing the unknown could be just to draw the red line and try to rigorously identify all the imaginable solutions to one given design question. You understand now the rigor is how to draw the red line with a maximum of extension. You probably know that to draw this red line, all the imaginable solutions, we have many methods available. And I won't go too deep on this, but this could be trial and error or problem solving or combinatorics, etc. What is interesting is that those methods are certainly exploring the unknown, absolutely right, but they tend to neglect the question of fixation. And finally, and I have no time for this, but we can show that, finally, all these methods don't control the fixation. So there is a lack here of rigor. We need a solution that is more rigorous in the exploration of the unknown. I won't show that here, but you can read the slides. This is the game with design theory. One of the aims or goal or purpose of design theory theorists, researchers working on design theory, is to increase the precision of this extension of all the imaginable solutions. So really increase the quality of our covering of the representation of the unknown. This is, of course, you understand, not decision theory, and it's not creativity theory. Creativity theory is not controlling cognition. It's just saying people are fixed and we don't know what to do. You should try to have more ideas, but we don't know where are the fixation, we don't know why, and we don't really work on how to overcome this. So design theory is another field. It's neither decision nor creativity. It's precisely the field where we explore how to have the maximum generativity for one given design issue or design question. By the way, you understand that when you work on this logic of generativity, you will have to both be extremely creative, but as well be extremely knowledgeable. So this will necessarily be a way to combine a theory of knowledge with a theory of creativity in the most rigorous way. Again, given the time, I won't go in depth on all the available theories, but if you are interested, we can provide many papers actually, and you're again very welcome to the next meetings on design theory. This is exactly the kind of question we work a lot on. But to say things very briefly on this question of design theory, you can see two main trends in the literature. The first one, historically speaking, is the so-called German schools, we could say, which is the classical engineering design. Explore the functions of the object, explore the conceptual models for this object, explore the embodiment of the object, optimize all the technical details of the object is a way to overcome fixation. Don't go too fast, too well-known solution. Rigor, maybe your functional requirements are different. Maybe there are now new knowledge on technologies, etc. So classical engineering design is a very interesting way to overcome some fixations. The problem is that it works if you have already a lot of pre-existing knowledge. You need a lot of top-level libraries on functional requirements, on design uses, on technologies, scientific models, etc., etc. So this is generative, very good, but it depends on your object models. A second tradition that Sub knows very well of is a decisional school, but more precisely the Simonian school. Many researchers say for now half a century, decision is not enough. We need to add something to make that the decisional framework can be extended to generativity. And they worked a lot on developing algorithms, developing computational models to precisely have a language that is this time universal, doesn't depend on object models, is very, very generic, and yet is generative. The problem is that there are limits to the classical algorithms developed by Simon, and Sub can build on this, of course, a lot, so that finally on the right-hand side, this is a very universal situation, but with limited generativity. And the great challenge for contemporary design theory is to combine both schools, to keep the generativity of German school and to combine it with the universality of the American one. And there are many propositions that try to do this. I just mentioned some references. I really would advocate general design theory by Yoshikawa and Tomiyama, or axiomatic design by Naipio Su, or coupled design process by Joachim Reich and Dan Braha. Well, all these are interesting propositions and they build one on each other. This is a rich world of exploration. One of these proposals is the CK design theory that is connected to all the previous ones. And for the presentation of today, I will now give you some insight on how CK theory works. Usually, at this stage, I start a long explanation of what is C, what is K. C stands for concept, K stands for knowledge, and I tend to explain what are the theoretical bases, the foundations, the theoretical foundations of CK theory. It's relatively boring. It's already written several times. So what I think is interesting for today is better to give you an illustration of this. If you want to have slides, if you want to have a long explanation, I can provide this. But I do think it's better to start immediately with a kind of exemplary case. So suppose that you want to design just a smarter shopping cart. You know, this cart that you have in supermarkets, and you would like to make it smarter, so more smart. You have knowledge in your case space, knowledge about the shopping cart, about what is shopping, about what is smart even. And you want to explore all the imaginable smarter shopping carts. Not only one, but all. That's a bit crazy. And I will show you how CK theory can work. And what you actually would like to do is to control your own fixation. So the best thing would be if the theory helps you to overcome your own fixation, to diagnose it and to overcome it. And there is a simple way to do this with CK theory, a kind of heuristic way of using CK theory. I show you how it works. So what you would like to do is to explore the space of all imaginable solutions to the smart shopping cart problem and create knowledge associated to this. So you would like to fill in a way the red boxes on the left-hand side, on the right-hand side. And I show you a heuristic to maybe not cover everything, but have already a quite interesting defixation effect. I show you how it works. The first step is, so remember, this is the exercise. I show it in front of you. The first step is not go to CK immediately. Just we create a kind of reference. And you could, unfortunately, we don't have time for this, but you could stop the video right here, and take 5 minutes and just write ideas that pop in your mind for a smarter shopping cart. And you create a list of ideas on your site, okay? Well, given the time, I won't do this now, but imagine you did it and you come back with a list of ideas. I wrote them on the right-hand side of this slide. Of course, you would dream the smarter shopping cart to help buy healthy food, for instance, or to help you be autonomous driving in the supermarket, maybe self-driving shopping cart, follows the user, finds promotion, use AI to optimize a shopping list, maybe entertain children, because you know it's not easy to have kids in the supermarket, or help you have an automatic payment, avoid queuing, or remind the shopping list, the fridge content, or help maybe elderly people to move or catch products. These are kind of creative ideas that pop in mind without CK, okay? And now we start using CK. And the first question for using CK is try to see if you can identify categories that are in several ideas. So for instance, again, you should stop here the video and try it on yourself, on your own ideas, and try to create the categories. One category could be many ideas here trying to optimize the shopping list. So this is a knowledge. You know that you could work on how to optimize the shopping list, depending on diet, depending on budget, or whatever criteria. Another category you see in the list here is many ideas are trying to improve mobility. Or a third category is many ideas in this list use data and AI software to help users. A fourth category is we identify types of users like elderly people or kids. So you create maybe here in that case 4 categories. You can check that all the ideas on the right can be related to one of the 4 categories that are here, okay? So this is your knowledge, and you discover that finally all the ideas that are here can be seen as a combination of these 4 categories. So finally, in the C space, you understand that you have generated ideas for smarter shopping cart that are using the category 1, or using category 2, or using category 3, or using category 4, okay? So this is a mapping. We just reorganize, as we usually do in a brainstorming. We start by reorganizing the original ideas, the chimeras, associated to smarter shopping cart. And now we can start wondering, are we fixed? Is this list of ideas limited or not? And you can test, and this is where CK becomes interesting. You could say, maybe there is a smarter shopping cart, so a concept, that is smart because it's not following the category, oh, sorry, this is category 4. So it's smart because it's not following one of the various users listed in knowledge. For instance, we could consider that we want a shopping cart that is smarter because it's smarter for non-users. Logically speaking, you have to reread the sentence. What about a smarter shopping cart that is smart because it is smart for non-users? Are we sure that there is no solution to that? Well, you think about it. Again, stop the video here. You think about it, and certainly you will immediately understand, or after a while, you understand, well, of course, we can see that the shopping cart is smart for the supermarket, or it could be smart for the product sellers, the producers inside, the producer of the product inside the supermarket. So finally, we were fixed. This nice list finally neglect the fact that it was not only done for helping the users, but a shopping cart could be done for helping the supermarket. And you think immediately about shopping cart fleet management. You can think about smart because it downsize costs, avoid checkout operators, optimize department management. You could be smart by having new businesses and sell advertising space. And all these are not specifically new. These are things that exist. They are in knowledge. But all those things, finally, are new resources that are not only useful to explore the crazy path smarter for non-users, but they can even be used for exploring the path that we had started with before. You would like to have a smarter shopping cart for users with an enriched interaction with the supermarket. What about providing a human help, a true human help service instead of having an object? Or maybe the shopping cart can be a mediator between the user and the producers, providing information, thinking about local producers or circular economy, all those kind of things. So finally, you understand that the knowledge you produce was related to crazy notions that finally can be useful for even the classical solutions. So it's just you understand, this is just a heuristic, but with that, you immediately understand key notion of CK. You understand that the concept space can be structured, that the knowledge space can be extended, and the game is to structure the concept to create new knowledge. So C will stimulate knowledge creation. Imagination, chimera are stimulating knowledge creation. And the knowledge you create have an effect on the C space. Knowledge will increase and not decrease. The knowledge will increase your imagination capacity in the expansive area, but even in the non-expansive area. So you have two movements: imagination stimulate knowledge, and knowledge stimulate imagination. And the CK logic is precisely in this interaction. And doing this, you can help a user of CK theory to overcome its own fixations. You see the mechanism, I hope at least. So with that, you have a reasonable example of a CK process. And well, we have worked a lot in studying the properties of CK. So I explained the C2K process and the K2C process. And the community is working on understanding these properties and understanding also deep logical aspects of the theory. With quite surprising results. For instance, I just give you some implications for the one of you who would be more interested in the formal issues behind it. There are very interesting properties. You can even explain in which situation you reach the limit. A certain knowledge structure could impede you to go further. It's you certainly have a kind of closed world. This is the so-called non-splitting situation, or we can identify so-called splitting condition. These are the conditions that warranty you be able to go out of the box in a way. Again, on formal models, what is interesting is that with CK theory, you have a quite powerful model for generativity. And one question of our funders, the companies that are funding our works, one question they had is, we see everywhere, they had it a few months ago, we see everywhere something around generative AI. And you claim that you are good in generativity. So could you please explain to us what is the generativity of generative AI? And how does CK account for the specific features of Gen AI generativity. This is a paper that has been published, but just to show you the good advantage of having a apparently abstract formal model, it's that finally you can really bring interesting, at least I hope, enriching answers to this type of question. Now, what I would like to do is to come back to my initial, you remember, my initial challenge. I wanted to tell the situation of managing in the unknown is to have a rigorous answer to this situation. You have a design problem, you generate ideas, and you would like to know if this idea have a bias, what is the cause of the bias, and is it possible to overcome the bias? So now I would like to close the loop and check whether with CK theory we can, in a way, prove that we have an interesting way to answer these questions. We did it almost 10 years ago, a bit more than 10 years ago, sorry, in an experimental way. So the question is really not really for technical innovation, but take it as a cognitive experiment. The question was, suppose that the design problem, the innovation question is, make that an hen's egg launched from 10-meter height doesn't break. And you can organize a creativity process, having a lot of ideas. So you will have students coming and they will ideate, there will be ideators, and they will provide a bunch of ideas, just like an innovation team. And you are the experimenter, and you would like to check whether the set of ideas is fixed or not. And you build the reference, the red line. To build the red line, you use CK theory. And so you make, strangely enough, you make a CK of make that an hen's egg launched from 10-meter height doesn't break. And this tree that you have in front of you on the C space is trying to map all the imaginable solutions related to this problem, and the K space is just mapping the knowledge used to create the C reference. So the red line is here on the left. It is all the different solutions that appear in the C space, and you can even identify, or at least you can predict the part of this long list, this part of this red line that is finally built on usually available knowledge, immediately available knowledge. So we guess that the part on the left is probably the fixation area, and the part on the right is the defixed area. So now you compare the prediction make with the design theory, you compare it with the reality of ideas provided by the ideator. And the answer is the prediction is quite good. You predict that a huge quantity of ideas will fail in the fixation area. So this quantity is finally 4 on 5 ideas are falling in the fixation area, and only 1/5 is out of the fixation. So you can at least diagnose the fixation, and you can even explain that this fixation is finally related to the fact that you don't use, you only use one part of the most easily available knowledge. The third question was, is it possible to overcome the fixation? And one classical solution is, what if I show an example to my ideators? I am a leader. Can I help my team to be more creative if I provide this team with one example at the start of the creativity process? And there was a fight in the community. Some say, in my experience, showing example defixes the team. Or others say, well, in my case, showing example increases the fixation. With CK and with this kind of design theory, you can predict. Suppose that you take an example from the knowledge that fixes people. Most probably the example will increase the fixation. Or suppose you take an example that is taken from the area of defixation based on knowledge that is usually not used. You have a great chance that the editor understands that he or she should use another type of knowledge. So if an example from the defixation area should defix, an example from the fixation area should fix. That was tested. So teams received an instruction that was make that an hen's egg launched from a 10-meter height doesn't break, and you should know that one team proposed to use a parachute. This is a fixation example. And another situation is make that an hen's egg launch from 10 meters, it doesn't break. And one team proposed to tame an eagle to catch the egg. So this is a supposedly defixation example. And you see the result when the team is given a fixation example. The number of original non-fixed ideas decreases. And when the team is given a defixation example, like the eagle case, the number of original ideas, defixed one, will significantly increase. So we have, at least here in the situation, a capacity to defix a team. That's interesting. This is a very modest management in the unknown, but it's a type of management in the unknown. This is just a lab experiment, but what is very striking that this lab experiment that was conducted at that time by my colleague Marina Goguet, she's now a professor in Montreal. She not only made an experiment, but she also studied a real case situation with the same technique. So this time the true question is support autonomy of elderly people, which is a critical, it was at that time already a very critical topic in France. This is a critical topic in many countries in the world. And there were goals, there were projects funded to help find solution to support autonomy of elderly people. And she makes a fantastic work. This is just a very simple, simplified summary that you have in front of you. She really mapped with CK theory all the imaginable solutions to the problem support the autonomy of elderly people. This is the CK tree you have in front of you. And she compared this with all the ideas that were proposed to two goals, one launched by a French region and one launched by the European Union on the same topic, more or less at the same moment. And the black dots you see on the map, on the C reference, are the proposals given to the call. And you see immediately that there is a terrible fixation. This is not a fixation at the individual level, but it's a fixation at the global ecosystemic level. Meaning that even if you have a lot of people providing ideas, even if you try to cover the fixation by numbers in a way, by playing numbers, finally, there is a great risk you won't overcome fixation. So even in situations where you have maybe thousands, millions of ideas, you go to the crowd, the fixation effect might still be here. That's quite terrible, meaning that managing the unknown is really a key issue. Okay. She made it on other cases. She called it a situation of so-called orphan innovation, meaning situations where finally we don't explore rigorously, we don't manage the unknown rigorously at ecosystem level. So just to mention to you some simple application of CK theory. At that point, I would like to just give you a hint of cases. Actually, we worked on this. We, my team, others in the world have developed a lot of methods, organization, processes to support the management in the unknown, and more specifically, to support the organization and processes of innovation departments in companies in particular, or R&D departments. There are many publications on it. I won't go too deep in this because I prefer to go to a different case. This is not an innovation department case. It's a more generic one. It's a crisis situation. We as a team were involved in that case, and the question came to us, my department, at the start of the COVID crisis in France. The hospitals in Paris, they predict they had to open emergency units very quickly. So they wanted to have ICU, intense care unit, to open. They wanted to open 1,000 beds. So it might sound not that many for you, but for us, opening in Paris, opening 1,000 new ICU beds was a terrible challenge. In Paris, you have 600 ICU beds in regular time, so it's more than doubling that number. And they wanted to do this in a couple of days. So this is a real challenge. And they ask us, could you please help us to find at least one equipment for these ICU beds, which is a so-called electric syringe pump. You might know what it is. This is that kind of electrical device, plus the system here, the robotic system, where you can automatize the movement inside the syringe, and you can use drugs with a very, very specific doses. And for an ICU bed in France, you need 5 or 10 of this electric syringe pump for each bed, meaning that they were looking for something like 5,000 to 10,000 ESP, electric syringe pump, in a couple of days. And the market for these pumps is approximately a couple of hundred per year. So you imagine the nightmare to find this products in a strong shortage. We were mobilized to find solutions, and well, you understand, we only can do design method and design theory, and our question was, can we rigorously map all the imaginable solutions, but map them to the point where they are not only imaginable but even feasible? So we would like to map to the detail where they are so detailed that finally someone can do this, even in the COVID period. And strangely enough, when you do this with this kind of design theory, you increase. But what you see here is a first map of all the imaginable solutions on the ESP case. It's at the start of the process, and we worked regularly with this, increasing the precision in each of these different directions and increasing the knowledge. And we did it, we started alone in a way, and step by step, we did it by including many, many different idea and knowledge providers. And we really reach a large set of knowledge and ideas providers that you see here, the 11 networks of people that were mobilized in this exercise. And we increase the connection between many of them. And step by step, what you see here is the list of all the projects, so the final leaves in the tree in a way. They're now written horizontally, and you see all the different solutions that were explored over time, leading to a situation where you can create a set of alternatives and combine all these alternatives to have a good chance to, in the end, overcome the shortage. And interestingly enough, what you see here, this is a synthesis we gave to the French hospitals, explaining where the syringe pumps are going to come from and who is going to provide solutions or part of solutions, and make that all the people that were connected through the CK process, all these people finally act in a connected way. So what is interesting, the CK process enables to create new relations, new social relations, new collective actions, not by having ideas for the others, but rather connected people so that the scattered ideas can be connected into something that is in the end coherent. So it's a very strange way. For us, it was a discovery. It's a very strange way to manage in the unknown by connecting creative ideas, creative people that are acting each in their own field, but they miss the vision of the obstacles. So providing this mapping of the unknown helps support the coordination of people who might have not ever met, actually. So that's interesting. You provide them the means to work together. So more or less, that's what I wanted to tell you and show you this strange example when you can use design theory to manage in the unknown, even very complex situations where people step by step will know each other, even if they didn't know each other at start. I hope I make the point. Managing rigorously and collectively the unknown is a critical issue for contemporary management. Design theory can be a rigorous framework to increase the rigor, maybe the quality of this management in the unknown. And this can then develop, unfold in different methods, processes, and organizations, from innovation to crisis management. Well, again, we do think it's just a start. We probably have to work a lot on managing in the unknown and developing new methods, organization, expertise, and competencies on it. It's probably a question of collective culture at a firm level, at a team level, at a firm level, at an ecosystem level, maybe at a societal level. And this is where we deeply work with the group of design theory to develop this culture with new industry, in science, in education. And this is where we would be very happy to go on working with all of you further in this Managing in the Unknown program. With that, I stop here.
Thank you very much, Pascal, for this lecture. I just want to mention to the participants that if you go to the CREE webpage, there is a lecture from before by Jacqueline Nagel as to how she is using CK theory for bio-inspired design. It might be something which you can see how it is being used in the teaching context every year by Jacqueline, especially for bio-inspired design. I just wanted to make that remark, and I'll hand it over to Sudhir. Yeah.
Jacqueline made a fantastic work. Thank you, Seb, for mentioning this. This is very important.
Thank you, Pascal, for taking us through this talk and primarily talking about distinguishing managing uncertainty from managing the unknown, and also highlighting the importance of becoming aware of fixations, as well as introducing the CK theory as part of this. I'll open the floor for any questions that participants may have. Maybe I'll quick start with one question. So when we are talking about overcoming or becoming aware of fixation, so are you linking this part to actually the managing the unknown? That is, if I'm able to go beyond my fixation, does it enhance the capability to manage the unknown? Is that what your main argument is?
Yeah, the first argument is that one. It's you can help experts and you can help individuals to overcome their own fixation. This is often what we teach in industrial design schools, for instance, or when we say to scientists, be curious, pay attention to anomalies, etc. So teaching how to overcome fixation, your own fixation, is the first part. But what is very important, in many cases, I show you, it's not only overcoming your fixation, it's helping people overcome their fixation. And management is not only about managing oneself, it's about managing the team or the group of people or the society. So the key issue might also be to find ways of organizing so that collectively we can overcome our own fixations. This is maybe the most difficult part.
So if I have to draw parallels with what we are currently attempting here, suppose I take an academic discipline, knowledge base in an academic discipline as a given, right? And then we start asking the question, can we produce a new breed of an engineer with this knowledge base? So then the question becomes, is there a fixation in this knowledge base which needs to be challenged to actually create a new breed of engineer? Because we are currently asking whether I can produce engineers who have more entrepreneurial orientation. Can I produce engineers who have more product design orientation, right? So which cannot happen if the fixation in the current knowledge base is actually challenged, isn't it?
Interestingly, I would say there will always be a kind of fixation associated to knowledge. You can never provide all the possible knowledge to avoid any. This would mean that you refuse that there is a known. You try to provide all the knowledge to avoid the unknown. So maybe the critical issue is much more how to teach people that for any given knowledge in any engineering discipline or any academic field, how to teach people be aware of the limit of their own knowledge. And they will complete. They will be more at ease in the unknown to learn, create knowledge, discuss with people, acquire knowledge, or create collaborations. The dream is not to have all the knowledge possible. The dream is much more to map the unknown and explore the unknown and be at ease in the unknown. Often, at least in our culture, we tend to teach engineers as knower, people who know. And when they don't know, when they are confronted to the unknown, they are stressed because they think they are not experts. It's not true. We should teach that an engineer is one expert of the unknown. Not knowing is not a default. The problem is not knowing how to handle the unknown. So we should teach engineers, we should teach scientists to manage the unknown, not to suppress it, to live with the unknown, to organize the unknown, to explore the unknown, to structure the unknown, but not to suppress it. That's one of the great distinctions between managing uncertainty and managing the unknown. Managing uncertainty is decreasing uncertainty. Managing the unknown is not decreasing the unknown. It's expanding, exploring, structuring, representing. That's that language. So you see the trees, the sea space is a space of the unknown. Even if it's unknown, you can say things, structure things. You have this tree structure. The tree structure describes the unknown in a way. So it helps you live in the unknown, not suppress it. That's probably the critical difference.
Yeah,
between
so
uncertainty
this
and
actually
unknown.
has implications for curriculum design, because when knowledge keeps expanding, we
Yeah.
tend to pack a lot more into the
Yeah.
curriculum instead of packing more and then struggling with what has to be left out. Probably we need to find a way by which
I
this
agree.
capability can. Yeah.
I completely agree. And this is probably one of the challenges we'd like to work on. What could be a curricula that better prepares students, whatever the discipline, better prepare them to live in the unknown and, well, organize, reason, be rational in the unknown, be rigorous in the unknown.
Professor Sudhir, I want to just not a question, it is sharing some point. See, whenever we are having some fixation and we have to enter into unknown territory, unknown problems, uncertainties, there is a concept called how to handle it by taking a concept called SCA model. It is called a model for knowledge creating process developed by Tanaka and the two Japanese. I just forgot their names. I read their book, in fact, Knowledge Creating Company. That is the title of the book. And Takochi and Nanaka. And they mentioned a good model. This is called SCA model. Socialization. You have to interact with others. You have to generate new ideas. And you have to externalize those ideas. That is called the socialization, externalization, and combination, and internalization. This is a model called SCA model. So that you can create new knowledge to
True.
manage the uncertainties, to overcome the fixations. So this is a good theory is available. I want to share this idea.
Thank you. Yes, we Nonaka's works and this process of knowledge creation, knowledge sharing are of course absolutely critical. Maybe where design theory might have something to say, it's to help people go beyond their classical social network, go beyond their immediately accessible knowledge, go to experts, go to cultures that might have not been considered without that. The difficulty is when you tell to people you should have social relations or you should be curious. This is what is said to scientists, for instance. This is an interesting recommendation, but it doesn't really protect you fully against fixation. Because you tend to discuss with people that are here, or you tend to be curious on areas you are already curious in. In a way, of course, this is true. You should learn, you should have social networks, etc. But how do you identify your own fixations? And this is where design theory is interesting. It could help you think, I like this expression, but it's strange, think against yourself. When you follow the recommendation of the learning, you think a little bit with yourself, even if you're ready to be surprised. But it's a random process. And in this kind of random process, fixation are uncontrolled. Being able to think against oneself, this is why I showed you this smarter shopping cart case. Being able to think about against oneself is having the capacity to say, oh, I recognize that I am trapped in a certain box, and I can formulate a kind of request, a prompt, I would say. I can formulate a prompt that will push me out of my comfort zone, out of my box in a way. You see the tactic, and maybe the critical issue for design theory is having a kind of rationality to create logically the proposition that will help you go beyond your fixation.
So just to add to what Pascal said, if you remember the example in the Nonaka book, he talks about bringing the bakers and Panasonic people, and they actually went to the hotels and saw how bread was made. This is a very good example of bringing two pieces of knowledge together. I'm making a bread machine, but I should know what should be a good bread in order to make the good machine. So to extend that knowledge, I require that I understand the baking process by actually participating in the baking process with the chefs, which is what they did. In some sense, CK theory can explain many of the things Nonaka talks about while providing a method to think about generation and, of course, internalization and creating collective memory. Those are all integral to the overall organization. But it's the creation process that always brings about different pieces. And I'll give you one more example where the Japanese luxury cars were the first to incorporate EC, electronic control units, for the entire engine before many of the others. That is because their Ministry of Trade and Industry continuously brings different industries together to solve future problems. And this is at a national level. And you can see that knowledge generation is at the heart of a society's productivity, society's enhancement. So in a sense, I think the point you're making is very important, Professor Shivkumar, that Shivaramakrishnan, sorry, Krishnaya, sorry, I just got to see the name properly. My apologies. I think in a way, in the Indian context, we have a phenomenal potential for mobilizing knowledge of the past and knowledge of the present and the potential knowledge of the future if we create the right kind of environment and institutions to actually be able to put them together. And I'll give you just quickly one more example. I used to teach a product design course where we had students from everywhere, from industrial design to computer science, engineering, and so on. And it was very fascinating because in order to remove oil, DuPont had told us use lycra, find uses of lycra in other places. One of the students said, oh, I'll take a big fish like a whale and attach the leaded lycra fabric. And this is radically crazy idea, but it gave a lot of other ideas. Instead of a whale, you use a ship, you use something else. So you see this composition of knowledge from different places allows you to be generative. And CK provides adding knowledge and creating new concepts. And this is something that I think not just the individual level, as Pascal said, at the social level, at the team level, at the national level, all of these things make a difference in terms of the space for composition of knowledge. I hope it was okay, Pascal, just to add to your stuff.
Thank you. Very good point. I fully agree.
So if there are no more questions, then thank you, Pascal, for taking time and sharing your perspective.
Thank you for the invite.
We appreciate, and this is being the 50th talk, it was quite appropriate that we brought out a significant contribution from your side as well. Yeah.
I just want
Thank
to
you so much
mention something that every year, end of January, we have the design theory workshop in Paris. If you send us a mail, we'll make sure It's a 2-day workshop, and we also have a 3-day PhD forum where we take PhD tutorial for design, where we get students from different parts of different universities in Europe and other places, where they go through this process of understanding many of the pieces Pascal said and other design theories, so that they have a good understanding of what design is in a much more global and local sense. So you're all welcome to that. I'm a co-chair with Pascal in that. So please, we would love to have it. Sudhir has been attending for 2 years now. And this whole program has been going on for the last 16 years. And I want to mention Pascal and this group have been instrumental very much, even though I'm part of it, more on a day-to-day basis in making these workshops really to be realized in a way that many people participate.
Yes, thank you, Seb, and really we would be more than happy to welcome you in Paris for the next workshop in February 2026. This would be a great opportunity to discuss further those topics, and I would be very happy to know more about what you do and how you might be interested in using it.
Thank you. Thank you, everyone, for joining today's session. This lecture will be posted on the CREE website shortly. And we will also update you on the next talk, which will come up in around 9th July or so. Thank you very much.
Thank you, Professor Sudhir.